Hello everybody and welcome to part 2 of this tutorial series. If you've not already, make sure you check out part 1 where we coded out the server. Now in part 2, what we'll be doing is building out the client. That means that we're actually going to handle the connection to the server from our different client devices, and we're going to build out a bit of a game interface, so a front-end user interface that can display the questions to the user, allow them to answer it, and essentially interact with the server by sending the messages back and forth. This will really tie all of the theoretical concepts together and make it crystal clear how this system works and actually show you a real implementation. Before we get into that, I'll remind you again, my name is Tim, I'm a developer advocate for this channel, and I run the Tech with Tim YouTube channel, which has hundreds of other programming tutorials. If you're interested in programming, make sure you check out my channel, and with that said, let's dive into part 2. Alright, so let's go ahead and get into it. Now what we'll be doing in this video is just writing the client, so what we're going to do is create a new folder here called client. Inside of here, similar to last time, we're going to make an init.py. So __init_.py, and then we'll create a few files. We're going to have game.py, which will actually be the pygame window. If I haven't mentioned yet, we're going to be using pygame as our front end kind of graphics. Very simple. Don't worry if you don't understand it. I'll explain it to you. We're going to create protocols.py. Now, this isn't ideal to just be copying this file, but to save us from kind of a bit of a madness here in terms of Python packages, I'm just going to copy the exact same file inside of here. And then we're going to have client.py. So let's first go to protocols from our server. Just copy that and put that inside of the protocols in our client. Not best practice, but again, it's just going to save us a bit of time in this video. And now we'll start writing inside of client.py. Now, the idea is we'll actually write a client inside of a class. This client will handle all of the communication with our server, and then we'll use this client from our game window so that we're separating out our different logic. So all of the client or all of the kind of socket communication code goes inside of here, and all of the actual game logic where we're displaying things on the screen and using pygame goes inside of game. So we'll begin with client, and then once this is finished, we can actually hook it up inside of our game. Okay, so inside of here, we're going to import socket. We're going to import threading. We're going to import JSON, and we're going to say from protocols, import protocols like that. Now you'll notice that this will be quite a bit easier than the server because now we already understand the protocol and the kind of communication method. So all we have to do is handle the different responses that we're going to be getting from the server and sending data to the server. So we're going to say class client like this. And we're going to say define __init. We're going to take in self, host, and port. Now the port will be equal to that 555. And the host will be equal to 127.0.0.1, which is simply localhost. And we'll change this when we actually do our deployment. Now inside of here, we're going to set up a few variables. We're going to say self.nickname is equal to none. We're going to say self.client is equal to socket.socket. We're going to use the exact same stuff that we did before. So socket.af_inet, and then socket.sock_stream. Then we're going to say self.client.connect. Notice this time we're connecting to the socket, and we're going to be connecting on the host and the port. Okay, now we need to set up a few variables which are going to be kind of responsible for our game state. So we're going to say self.closed is equal false. Now that means that we are closing the socket, so we're no longer connected to it. That's an important thing that we need to know because we don't want to attempt to use the socket when it's closed. If it's closed, that means we can't use it because we've disconnected, okay? We're going to have self.started. So remember, we get that started message from the server. So we're going to kind of update this variable when we get that message. We're going to store the different questions that the server returns to us. So we're going to say self.questions equal to that. And we're going to keep track of our current question index, which is equal to 0, and then the opponent question index as well, because we want to know both of those indices so we can display them on the screen. Next, we're going to have self.opponent_name is equal to none, and then self.winner is equal to none as well. Okay, so those are all the variables related to our game state. Now, we can start writing a few different methods that we need. So we're going to have a start method. This is going to actually start our client. We're going to have a send method. Okay, this is going to send something to our server. we're going to have a receive method, which is going to run in a separate thread, and it's going to receive data from the server. So we have start, receive, and send. We're going to have a close method, which is going to close the connection. We're going to have a client validate answer method, which is going to validate if the answer to the question is correct on the client side, just so we can avoid some latency issues. So we're going to take in the self and attempt. And we have a few more here. We're going to have define handle response. We're going to take in self and response. And this is similar to what we had on the server. We're going to handle the response from the server inside of here. And then lastly, we're going to have define get underscore current underscore question, which is simply going to return what the current question is that we are on. We can do that fairly straightforward. Okay, so let's begin by writing our receive method, and then we'll move on from there. Now, similar to how we have this working on the server, what we want to have is one separate thread, which is responsible for receiving all of the different data from our server. That means that when we're running the main game, we can have that in a separate thread, so there's no latency or no blocking going on between the code that's kind of running our game and running our user interface and the code that's handling the communication with the server. Okay, so here we're going to have define receive. We're going to say while not self.closed. So while the socket is not closed, we're going to try to do something, and we'll accept it down here and just break. Okay, so inside of try, we're going to say data is equal to self.client.receive 1024.decode, and we're going to attempt to decode this using ASCII. And really, we could call this server. That probably makes a bit more sense, actually. So we're going to say that this is server, and we'll change this to self.server.receive. So now we're going to say our message is equal to json.loads. Remember, we're always receiving JSON data. And then we're going to call self.handleResponse, and we're going to pass to it the message. Okay, perfect. So that's actually all we need inside of receive. And then down here, we're just going to say self.close, because what we're going to do is say, okay, well, if we broke out, so if something went wrong here, we want to close the socket, and we can simply write close here as well. Self.close equal to true. And then self.server.close. So we just close the connection with that socket. All right, so now let's write our handle response and our start. And we'll actually go with start first. So for start, this is going to be pretty basic. We're just going to say the receive underscore thread is equal to threading.thread. And we're going to say the target is equal to self.receive. And then we'll just say the receive thread.start. That's it. We just want to make sure that as soon as we start the client, we put everything that we're doing inside of the client for receiving data inside of a separate thread. Great. So we have that now. Now we're going to go to handle response, and we're going to write the logic to handle the different data that we receive from the server. So we're going to say our r underscore type is equal to response.get. This is all going to look very familiar because we've already pretty much done this, but this is just going to be type. We're then going to say data is equal to response.get, and we're going to get our data, and then we're going to check what the different response type is, and then handle our data accordingly. Now, this is where the response type actually comes in handy, because if we go look at protocols here, you can see we have a bunch of different responses we could be receiving. We could be getting nickname, question, start, opponent, opponent advance, all these different things. We need to handle all of them so we know what to do based on the certain type of message. So I'm going to say if r underscore type is equal to protocols.response.questions. Well, that means they sent us the question data. So if that's the case, we're going to say self.questions is equal to data, because that will just be storing the questions. Otherwise, if the r type is equal to protocols.response. And in this case, we can do opponent. That means we're getting the opponent's name. So we're going to say the self.opponent name is equal to data. We'll say elif the r underscore type is equal to protocols.response.opponent advance. Well, if the opponent is advancing, that means their index has gone up. So we're going to say self.opponent question index plus equals 1. Elif the r underscore type is equal to protocols.response.start, that means we're starting. So we're going to say self.started is equal to true. Elif the r underscore type is equal to, what is this? Protocols dot response dot, in this case, it is winner. Well, that means someone has won. So we're going to say self.winner is equal to data, which will be the name of the winner. And we're actually going to call self.close because if we won, that means we want to close the connection because we're just going to have to reconnect to play another game. And then we'll say elif the r underscore type is equal to protocols dot response dot opponent left. Well, if the opponent left, unfortunately, we need to close the socket. So we'll say self.close, meaning, hey, our opponent left. We have no one to play against anymore. So we just leave. We're going to disconnect as well. That's handling response, and that's all we need to do inside of here. Again, pretty straightforward. We're just looking at the type of the data that's coming in, and then we're essentially assigning that data to the correct variable or doing what it is that we need to do. All right, now we can write a few other things. Let's go ahead and write our send method, and then we'll actually start using all of this from our game, by the way. This is just kind of the main logic that we need to have set up. So for send, I forgot to write these parameters, but we're going to take in a request and a message, and we're going to do the following. We're going to say data is equal to type. That's going to be equal to our request. And then we're going to say data is simply equal to our message. And then we're going to say self.server.send, and we're going to send the json.dump_s data.encode. And we need to encode this using ASCII. Okay, so that is our send method. And then we have two more methods left to write: client validate answer and get current question. So the whole point of this client validate answer is that it's going to take a few milliseconds or a second or however long it takes for the server to actually give us a response that tells us if we got the question correct or not. So we could simply wait for the server to respond to us and tell us, hey, the question was correct or was incorrect, or we can just check that ourselves by using the question. Now, there are a few potential issues with what I'm about to do here, but this is going to remove any sense of latency that you might have. Again, you don't need to do it this way. There's all kinds of different approaches, but just bear with me. The point of this is that we're instantly going to validate if it's correct or not, so that we know on the client side if we got it correct before waiting for the server to give us that response. Now, again, you'll kind of see why this might be buggy depending on, the latency you have and how far away your clients are, but it should be okay for right now. So we're going to say the question is equal to self.questions at the self.currentQuestion index. Now remember, our questions are just regular expressions, right? It's like 1 + 1, 2 + 2, 1 - 3. Now in Python, what we can actually do is use something known as eval, where we're going to evaluate what the code is inside of this kind of string. Let me just say this again. Eval takes in some kind of string, which is a Python expression. In this case, the expression could be 1 + 1. If it's 1 + 1, eval is going to return 2. Now, eval is a little bit dangerous to use because of the fact that it evaluates any Python expression, which means if you pass something like answer equals 10, it will actually change the value of this variable. So you have to be careful using this, and it's probably not something I would recommend having in any type of production code. In our case, this is very simple. We're just doing kind of a quick math quiz game here. It's a learning experience, so it's fine for us to use eval, but I'd recommend don't use this in any production code because it can have some security issues. Anyways, we're going to say answer is equal to eval just to kind of quickly evaluate what the answer actually is. And we're going to say if answer is equal to the int of attempt, just because attempt will be a string, so we want to convert that to an int, then we'll simply say the self.currentQuestionIndex, current question index like that, plus equals 1. So that is client validate answer. And then lastly, get current question. Well, to get the current question, actually, we can just do what we had here. Take that, return that. And is there anything else that we need to do here? Actually, I should just do a quick check here. I should say if the self.currentQuestionIndex is greater than or equal to the len of self.questions, then we'll just return an empty string just so we don't get an index out of bounds exception. That actually reminds me, for client validate answer, we should just use that method. So self.getCurrentQuestion, so we avoid any index out of range exceptions. All right, so I think that's actually going to wrap up the client script. Let me just zoom out a bit and we can kind of go through this line by line. So we have our initialization. So our nickname is equal to none. We take in our server. So we kind of create the server, which is connecting to the socket. We then have a few variables here for our game state. We have our start method. The start method is simply going to create a new thread for the receive method, which is going to handle all of the receiving data from the server so that we're not blocking when we have our main user interface in game kind of using this class. Next, we have send. Pretty simple, just sending some data to the server. We have receive. This is just running in an infinite loop, getting all this data that is received from the server and then handling that as we receive it. So we're kind of passing this off to handle response. And if anything goes wrong here, we're just going to break and then close the connection. Closing the connection, we just simply say, hey, yep, we're closed. So self.close is equal to true, which is going to stop running this while loop. Well, we'll already stop because we broke out, but we could close in other scenarios as well. Anyways, then we're going to say self.server.close, which will close the socket connection. Client validate answer, we just wrote that one, so I'll skip over that. Handle response, we're just taking in some data from the server and handling what that data is and setting the appropriate variables to the data that was returned. Get current question, pretty straightforward, just returns the current question with a bit of a kind of catch here to make sure we don't have an index out of bounds exception. All right, client is written. Now we need to go into game. Now game is where we're actually going to set up our pygame window and start using this client to communicate with the server. So this is where it starts to get a bit more interesting. There is a bit of code that we need to write here because we have some UI implications where we need to kind of display some stuff on the interface, but let's go ahead and get started. So first of all, we need to make sure that we have pygame installed. So let me just get out of my server. So I'm just going to close that. I'm going to open up a new terminal window here. I'm going to cd into my client, and I'm just going to type pip install pygame. So just make sure that's installed wherever you have Python. You also can do pip3 install pygame if you're on Mac or Linux, or python-m pip install, or python3-m pip install. Those should allow you to install pygame. Okay, just showing you a few different commands there in case the first one doesn't work. All right, now that we have pygame installed, we can import it. So we're going to say import pygame, and we're going to say from client, import client, and from protocols, import protocols like that. We're now going to set up a class for our game. So we're going to say class math game like that. We're going to define an initialization. So define init, and we're going to take in a client. Now what we're going to do is say self.client is equal to client, and we're going to say client.start. Perfect. So now we have that, and we're going to set up a few different variables that we need here for the game. Now, if you're unfamiliar with pygame, this is a 2D graphics library. It allows us to very easily create some 2D games. In our case, we'll just be using it for some input boxes, some text, very simple stuff, just so we can see kind of what's going on. You could do this probably a bit easier if you're using something like Kivy or PyQt, but we're just going to use pygame because that's what I'm most familiar with. And if you wanted to make a more advanced game, you'd probably be doing it in pygame if you were working in Python. All right. So we're going to say self.font is equal to none. We're going to say self.inputBox is equal to pygame.rectangle, and I'm just going to set the coordinates for this rectangle. So I'm going to put this at 100, 100. I'm going to give this a width of 400 like that, and a height of 32. Now what I'm doing here is setting here, first of all, the X coordinate, and then setting the Y coordinate. Now the way the coordinate system works in pygame is you have the top left-hand corner of the screen being 0, 0. Meaning as you go to the right, you increase in X, and as you go down, you increase in Y. So having 100 here means I'm going to be 100 pixels off of the top left-hand corner of the screen in the vertical direction. Then you have the width and the height, which is straightforward, the number of pixels for the width and the height of this input box. Next, we're just going to set up some colors. So I'm going to say color inactive is equal to pygame.color. For this color, I'm going to go with the light sky blue 3, and then I'm going to say self.color_active is equal to pygame.color, and this is going to be the Dodger blue 2 like that. These are just two colors that you can access in pygame. The reason I'm using these is because I want to have an inactive color state when I'm not highlighting the text box and an active color state when I am highlighting that text box. Then we're going to have self.color is equal to self.color inactive. We're going to have self.text is equal to an empty string. This is the text that you're currently typing in on the screen. So whether you're answering the question, giving a nickname, etc. Then we're going to have self.done is equal to false, and self.loggedIn equal to false. So there is quite a bit more code we need to write here, but I've just set up the initial variables. Now let's move on and kind of handle some of the logic for our game. All right, so we're going to say define run. We're going to take in self here. And inside of run, we're going to say pygame.init. This just initializes some fonts and other objects we're going to use. And we're going to set up a pygame screen. So we're going to say screen is equal to pygame.display.set_mode. And inside of here, in a tuple, you're going to put the width and the height of the window that you want to use. You can do it quite small. You can do it large. It's completely up to you. For me, I'm going to go with a width of 800 and a height of 600. This will fit on most of your screens, so you can probably just go with the dimensions like that. You can obviously make it smaller or larger if you want. Next, we're going to set up a clock. I'm going to say clock is equal to pygame.time.clock with a capital C. And then we're going to create a font object, which is something that we can use to render different text onto the screen. So I'm going to say self.font is equal to pygame.font.sys font like that. For the font, we're going to go with Comic Sans, and then you can put a size of the font, which I'm just going to make 32. You can make this any size that you want. Okay, so we've set up a few variables here. First variable is actually just going to create a pygame window for us that will pop up onto the screen. Second variable is going to create a clock object, which will allow us to regulate the frame rate. And then this is a font object that we'll use to render some different text. So now we're going to say while not self.client.closed. So essentially, we want to make sure the client is currently connected. If the client is not connected, that means that we need to end the game. So we have a while loop here where we're using from our client, right, if it's connected or not. Then we're going to say clock like this, dot tick, and then 30. What this means is that this while loop here can run a maximum of 30 times per second. If you made this 60, it'd be 60 times per second. You're essentially setting a fixed frame rate when you use this clock. It's important because if you don't do that, then the loop is going to run at a different speed depending on the speed of the processor of the host computer that's running this code. Next, we're going to set up something known as an event loop. We're going to say for event in pygame.event.get. What this is going to do is loop through all of the different events that have occurred and allow us to check through those events. So we're going to say if event.type is equal to pygame in all capitals .quit. Then what we're going to do is say self.client.close and then pygame.quit. This essentially means if you press the big red button in the top right-hand corner of the screen, we are going to quit the pygame window and we are going to close the socket connection, which will then cause our other client to disconnect, which is what we want. Okay, now otherwise, so if this is not the case, then we're going to say self.handle_event, which is going to be a method that we're going to write. And we're going to pass this an event, and that will handle the different events that are occurring. Then we're going to go down here, and we're going to say self.draw, and we're going to pass our screen. Again, this is a method we're going to write in 1 second. And I think that that's it for our main event loop. So anytime you create a pygame kind of program, system, game, whatever you want to call it, you have to write something known as an event loop. An event loop is what's going to loop continuously and look for all of the different events. So that's kind of what we're implementing right here. We're saying, hey, we're going to run this maximum of 30 times per second. We're going to loop through all of the different events. If you press quit, we're going to end the game. Otherwise, we're going to handle whatever event it is that occurred. And then we're going to draw whatever we need to onto the screen, which is what we're kind of implementing here. Okay, so we're going to say define draw. We're going to take in self and a screen. And we're going to draw something on the screen, which we'll do in a second. And then we're going to say define handle_event. And we're going to take in self and event and then pass like that. Okay, so the way that this is going to be kind of set up is when we first join, we need to make sure that we're asking the user to submit a nickname. So the first thing we want to draw on the screen is kind of an input box saying, hey, give us a nickname. As soon as they give us the nickname, then we can actually start playing the game. So we're connecting to the socket, submitting a nickname, and then we'll either be waiting for another player or we'll be instantly in a game and then we can start playing that game. So there's kind of 3 or 4 different states we need to draw. The first is that we're waiting for login, so we're waiting for them to give a nickname. The second is we're waiting for an opponent, and the last is we're actually in the game. Okay, so let's kind of implement those different states. We can do those beginning with the draw function. So inside of draw, we're going to say screen.fill, and we're going to fill this with white. Now in Pygame, you can use RGB color codes. So in this case, I'm using red, green, blue. When I fill this completely with 255, that means I'm doing all red, all green, all blue, which creates white. So I'm filling the screen with white. The reason you need to do this is if you want to kind of clear what was previously on the screen, you need to actually draw over top of it. So we're filling the entire screen with white, so it's essentially empty, and then we can draw new content on it. So what we're going to do is say if not self.loggedin and not self.client.started. So if we haven't logged in and we haven't started the game yet, then we're going to say self.draw_login. And this is going to be another method that we'll write in 1 second. elif not self.client.started. So if we are logged in, but we haven't started yet, that means we're waiting for someone else. So we're going to say self.draw_waiting, and we're going to draw whatever that screen is. And then otherwise, we're going to say self.draw_game, and this will draw the main game. Okay, so that's kind of our game logic. And then down here, we're going to say pygame.display.update. What this is going to do is just update the display with whatever we draw in any of these 3 methods. So the idea here is we're essentially just picking which draw method we're going to go in, depending on the state of the game. We're either going to be drawing the login, drawing the waiting screen, or drawing the actual game. Let's begin with the login. We're going to say define draw login. We're going to take in self and screen. For the login, we need to draw a prompt, so something like enter your nickname. Then we need to draw like a text input box where we're allowing the user to actually type some text in. It's not super easy to do that in Pygame, but we'll begin here. So we're going to say prompt is equal to enter a nickname. We're going to say prompt_surface is equal to self.font.render. Now remember, we created this font right here and we initialized that down here. So as soon as we have our font, we're going to start using that. So self.font.render, we're going to render this text. We're going to pass a 1 here, which stands for anti-aliasing. Don't worry about that too much. And then for the color, we're just going to do this in black, so 0, 0, 0. Now the way that render works is you have a font object, use.render. .render will take in some text that you want to display on the screen. In this case, that's our prompt. Then it will ask if you want to use anti-aliasing. In this case, we'll say yes. Then it will ask you for the color, which in this case is black. Okay, now that we have that, we're going to draw this on the screen. So screen.blit. We're going to blit the prompt surface. Now, the way this works is we have our Pygame window here, which we're kind of passing from here to here, eventually to here. So we're saying, okay, we have this font object that we want to display on the screen, and then it's asking us where we want to display it. Now, where I want to put this is at 100 and then 50 like that. Okay, so that just means we're going to put this at 100x, 50y. You can draw this really anywhere you want, but that's where I'm going to put it. All right, next we're going to draw a rectangle. So to draw a rectangle is a bit different. We're going to say pygame.draw.rect, and then we need to put the screen we want to draw this on. So I want to draw it on my screen. We need to specify the color. In this case, I'm going to say self.color. So this is either going to be the active color or the inactive color, because what we're drawing now is this input box. And we're going to say self.inputBox. So what is kind of necessary here, or what the argument is here, is a tuple of 4 things. Those 4 things are the x coordinate, y coordinate, width, and height. So whenever you're drawing a rectangle, you're going to be passing the screen, the color, the rect, so in this case, x, y, width, height, which we already have because we have a Pygame rectangle here, which can be treated just like a normal Python tuple. And then after this, we can specify the border that we want to have. So in this case, I'm going to go with 2, which means we're going to have a 2-pixel border for the rectangle. So rather than filling the rectangle in, we're just going to draw a 2-pixel border or outline on the screen. That's what this means right here. Now that we've done that, we need to draw some text inside of the rectangle, which is the text that we are kind of inputting with our keyboard. So you'll see what I mean in a second, but the idea is we're going to have a little rectangle, and then we're going to be typing some text. As we type that text, we're going to change this text variable, and then we're going to draw whatever the text is that we're typing onto the screen. So we're going to say text_surface is equal to self.font.render. We're going to render the self.text. We're going to pass a 1 for anti-aliasing. And then we're going to do this in self.color, which will be the active or inactive color. In this case, it will be the active color because we've pressed on this box. Then we're going to say screen.blit because we need to draw this text onto the screen. So we're going to do our text surface like that. And for the position, this is going to be the input box.x plus 5. And then the self.input box.y plus 5. The reason why I'm adding this plus 5 is because I want to pad a little bit off of the X and Y position so it looks like it's inside of the box, not on the border of the box. The way I can access this is on the input box, I have this X parameter, right? X is going to reference the X value. Y obviously gives us the Y value. So I see, okay, where is the top left-hand corner of the rectangle I'm drawing? Well, it's here. I'm going to add 5 pixels to that, so I'm a little bit below it and a little bit to the right of it, and that's where I'm drawing this. Now, I don't need to pass a width or height because we already have that from the text surface, and blit only takes the position where you want to draw this object. One other thing to mention here, when you are drawing objects, you're drawing from the top left-hand corner. So when I pass a position like this, so like my X, Y, this is indicating the top left-hand corner where I want to start drawing my object from. And then what we're going to do here is say self.inputbox.width or .w is equal to the maximum of 100 and the text underscore surface dot get underscore width like that. And we'll actually just add 10 pixels to that. Now, the reason why I'm doing this is because the input box will start at a fixed width. However, if I type something quite large, I could actually get outside of the input box. So what I'm doing here is saying, okay, I want the width of the input box to be a minimum of 100, but the maximum of either 100 or whatever the size of the text is that we're drawing. So if the text is 200 pixels, I want my input box to grow with the size of that text such that it appears larger as we write more and more content into the input box. You don't really need to have this line here. You could comment it out, but I'm just adding it so that we kind of get that dynamic growth of the input box. We could also just make the input box larger. A lot of different choices here, but this is what I decided to do. So now we have drawing the login. I think at this point, we can actually just initialize our math game, and then we can see if this is working and then add some more code. So what I'm going to do down here is say game is equal to math game, and then I'm going to pass an instance of my client, and then I'm going to call game.run, and I'm just going to put this inside of this. Okay, so this only runs if I run this file directly. Let's tab that in. Okay, so I've created an instance of my client, which I imported up here. Notice that's required inside a math game. Okay, then I call game.run. Now, it's possible that we're going to get an issue if our server isn't running. So what I'm going to do is just start my server. So I'm going to go cd server, python main.py. Now our server is running in this right terminal. And in the left terminal, I'm going to start my game, and we're going to see what happens and if we get any connection in our server. We should be getting a connection in the server because if we look at client, we can see that as soon as this initialized, we attempt to connect to the server. So we should see that over on the right-hand side. So if I go to python game.py, you can see this pops up here. And if we look in our server, we have a client that was connected. It says enter a nickname. Now notice nothing's happening because we haven't implemented that. And if I hit X here, you can see that it quits. Now it gets an error over here. It says an existing connection was forcibly closed by the remote host. That's fine. The reason we're getting that is because we just force quit the server. Right now, what we'll just do is just close both these windows and we can look at them again in a minute. Okay, so you saw that was working. Now what we need to do is handle kind of putting some text inside of that input box, which means writing this handleEvent method. So we're going to go to handleEvent and we're going to start with the following. We're going to say if event.type is equal to pygame.mouse button down. That means we press the mouse button. We're going to say if self.input underscore box dot collide point, and we're going to pass the event.position, which is really the position of our mouse. Then we're going to say self.color is equal to self.activeColor. Otherwise, we're going to say self.color is equal to self.inactiveColor or color inactive. Now, the way this is working is we're saying, okay, did you press on the input box? If you did, let's make the color active. Otherwise, we'll make it inactive. Down here, we're going to say if event.type does not equal pygame.keyDown or the self.color is equal to the self.color inactive, Then we'll simply return. The reason for this is if you're not pressing the key down or the color is inactive, that means you don't currently, or you're not currently typing anything in the input box, so we don't need to do anything. Otherwise, we need to essentially get whatever character you typed on your keyboard, and we need to place that inside of the input text box. So what we'll actually do here is we'll say if event.key is equal to pygame.k underscore backspace, then what we want to do is say self.text is equal to self.text and then :-1. Now what that's going to do is essentially remove the last character from our text. So we're saying, hey, if you hit the backspace, then we want to remove a character from the text. Otherwise, we're going to say self.text plus equals event.unicode. Now, you don't have to worry too much about how all of this works, but essentially for our event, we have a type. We also have a key, right? The key is telling us what key we actually pressed. So we're checking, is that equal to the backspace key? If it is, okay, remove a character. Otherwise, we can just get the Unicode character that you typed on your keyboard, and we can simply add that to our text, which will now show whatever key you're typing in that text input box. So let's try this out right now. Again, we're going to have to start our server just because we're trying to connect to the server. So if we don't have that, we may get an error. So I'm going to run my server over here. I'm going to go to my client. I'm going to type Python game.py. And now if I click into the box, you can see that it goes blue. And you can see if I click outside of it, it's kind of not highlighted. So if I click here and I start typing, you can see my text is appearing. And if I hit my backspace, it's being removed. Now it looks a little clunky here. I think we just need to make our text input box quite a bit bigger, just so it'll look a bit nicer. So let's click out of this and you can see that we exit. So let's go to our input box and let's just give the height of like 80. And I think that's actually all we're gonna need here. Yeah, I think that's fine. So now let's just restart our game. Okay. And now if we type, you can see that it kind of fills in here. We could actually probably make it a bit smaller. And notice if we make it larger, it kind of grows, right? And it will shrink here as we backspace out. Perfect. Let's close that again. And let's just restart both of these. Okay. And move on to the next step. All right. So now what we want to do is once the user presses the enter key, we want to take whatever they've submitted or whatever they have inside of the input box, and we want to submit that to the server as their username. Because again, what's happening is we're kind of connecting as a client. And then remember, if we go back to our server here, what we're waiting for is this handle connect to be finished. So we're waiting for the client to send our server the username. As soon as we send the username, we're either waiting for a room or we'll instantly be placed in a room where then we can actually start the game. So now we need to actually send that to the server. So if we go to game here, we're going to say if event.key is equal to pygame.k underscore return. I think that's the correct key. I believe it is. We're going to make this an elif. And then if you're pressing return, we're going to submit something to the server. So we're going to say if not self.loggedin, then what we want to do is say self.client.send, and we're going to send protocols.request.nickname. Now for the nickname, we're going to pass whatever the text is. So we're just going to write text like that. So actually, sorry, this is self.text. And then we're going to say the self.client.nickname is equal to, and this will be self.text. We're going to say self.loggedin is equal to true. And then we're going to reset the text to be empty. Okay. So if you're not logged in and you've pressed the return key or the enter key, that's really what that means. We're going to take the username and send that to the server using our client. Perfect. We're then going to set the client's nickname, set that we're logged in, and then set the text equal to empty. Now, while we're here, we can do the other state, which is elif self.client.started. So if the game has began, that means that now we're going to be submitting answers every time we type something in the input box. So we're going to say self.client.send. This is going to be protocols.request.answer. And this time we're going to convert our self.text into an integer because that's the answer that we want to submit. And then we're going to say self.client.client underscore validate answer. So remember I was saying, okay, we're going to send this to the server, but before we wait for the server to tell us if it's correct or not, we're just going to validate it on the client side. So what we'll do to validate the answer, it just pass in our self.text, and then we're going to say self.text is equal to an empty string. So that's it for handling our event. So now let's actually try this out and see if we're able to successfully send our nickname to the server. So we're going to cd to server, python main.py, cd to client, python game.py, brings it up. Let's type in something like hello, and then hit enter, and notice that we got an error here. That's fine. We'll look at that error in a second, but it says waiting for room. Since it says waiting for room, what that means is we successfully submitted the username. If we wanted to see some more information on our server, we can go over to server. We can go over to handle receive, and we can simply print out what the message is here, just so we can see that every single time we get one on the server. Anyways, you saw that that did work, and the error that we're getting here now is it's saying there has no attribute draw waiting. So we are now in the waiting state. We don't have any method for that yet, so we just need to implement that. So let's close these out. Okay, let's shut that down. And now let's go to math game and draw the rest of our draw methods. Okay, so we're going to say define draw underscore waiting, self and screen. And all we're going to do here is just draw some text on the screen that says we are waiting for someone to join. So I'm just going to copy what we have here, paste this. Rather than prompt, we can just put text, and text, and this will be text here. We're going to change this from enter a nickname to say waiting for player. Okay, and we can just draw this exactly where this is. We can draw it in a different location if we want, but I think this is fine right now. And actually, just because I want to show this to you, I'll show you how we draw it in the middle of the screen. So to draw it in the middle of the screen, I'm going to say screen.get underscore width divided by 2. And then that's going to be minus the text surface dot get underscore width divided by 2. You got to remember that we're drawing from the top left-hand corner. So that means I need to find the middle of the screen, which is the screen width over 2. And then I need to subtract from that half the width of my text so that when I draw my text, it's in the middle of the screen. If I don't subtract half the width of my text, then I'm going to start drawing the top left-hand corner at the middle of the screen, meaning the text is going to expand to the right of the middle of the screen. I want it to expand to the right such that it appears in the middle. So that's why I'm doing this right here. Hopefully that makes a bit of sense, but we'll do the exact same thing for the height. So just copy that in and go get height and get height. Not getting any formatting there, which is a bit annoying, but anyways, you get the idea. So this will do the same thing. And now we should be good for drawing the waiting screen. So let's try this again. We're going to go again, cd server, python main, cd client, python game, enter a nickname of Tim, and it says waiting for player. Okay. Now let's actually try to spin up another client and see what happens if we enter a username, if it kind of creates the room for us. So let's make another client here. cd client, python game. Now we have 2 pygame windows. Notice one of them is waiting and one of them is waiting for a nickname. Here, if I go Joey and I hit enter, we get waiting for player. Now we actually get an error on both clients here. And the reason we get that is it says it's waiting for draw game. The reason we're waiting for draw game is because now at this point, 2 clients have connected, the room has been made, and now these clients are waiting to actually play the game. So we now need to implement the draw game method, and then we'll be moved into that state. Whereas here you can see that it did create the room when that second client joined. So what I'm going to do is just quit both those windows here. Okay, so get out of those. And now let's go and implement draw game. So we're going to say define draw underscore game. We're going to take in self and screen, and we'll start writing that here. All right, so what we're going to do is we're actually going to take this input box, and we're going to put this in a new method. We're going to say define draw underscore input like that. We're going to take in self and screen, and we're going to call that from login. So self.draw input, pass our screen. The reason for that is we actually want to draw the input box on the login screen as well as the game screen. So from game, we're going to say self.draw input with the screen like that. And above that, we are going to draw what the question is. Okay, so it's pretty much the exact same thing as what we're doing on the login screen, except this time we're displaying the question, and that's associated with the input box. And I'll just make the input box a bit smaller. So we had it 32 before. Let's make it like 45 rather than 80. Okay, so now let's go to draw game. For draw game, we're going to say the question is equal to self.client.get_current_question. And we're going to draw this question on the screen. So we're going to say question_surface is equal to self.font.render. We're going to render an f string. The f string is going to have the question, but I want to have the question number. So I'm going to say self.client.current_question index : and actually we'll just do a dash like that, and then we'll display the question. We can put an equal sign there too if we want to make it a bit fancier. And then we'll put 1, and we'll draw this in black, so 0, 0, 0. Okay, so that's the question surface. Then we just need to draw this on the screen. So we'll say screen.blit, the question surface, and we can draw this at the position 150. Doesn't really matter where we draw it. That's where we'll go with for now. We need it to be question surface. Okay, so that is draw game. And that should actually be pretty well good for implementing our game. Let's see if that's the case or not. So our server's running. The server actually should continue to work right now without restarting it. So let's try this. We're going to go cd client python game.py and then cd client python game.py. Okay, so let's get both these clients. Let's go on this side. Let's type in Tim. Okay, let's go with on this one Joey, and then notice it brings us into the game. Okay, so we have 0 dash 1 plus 1 equals. Okay, so this is a little bit confusing the way I wrote this because the dash looks like it's part of the equation, but it's showing us that we have 1 plus 1 is the question. So let's go over here and try submitting the answer of 2. Notice when we do that, it brings us to the next question. If we submit the incorrect answer, it doesn't move us forward, but if we do the correct answer, it moves us forward. If I do 6, then notice it quits. And the reason it quits is because we just won the game because we finished and answered all of the questions correctly. So the game's actually working properly. And you can see over here, it's showing all of the different messages that have been sent from the client to the server. So that's working pretty well. Let's just continue here and make this look a little bit better. So for our self.current question index, we're going to add 1 to that. And we're just going to put a colon here because that's going to indicate better that this is kind of the number. So we'll go with something like number, whatever, and then actually show that. And you'll see that the game is pretty well done at this point, other than handling the end screen and showing the kind of opponent data, which we're going to do in 1 second. So just run this one more time. All right. Let's go with Joey and Tim. Okay, it should bring us in the game. Question number 1 is this. So let's go with 12, 2, 2, 4, 4, and 6. And you can see again, it ends because someone won the game. Now what we need to do is handle displaying who won the game and then show information about the opponent so we can see what question the opponent is currently at, where we're racing to get the answers right as fast as possible. Okay, so let's bring this down. And we're going to go down here. And what I'm going to do is call a new method. And this method is going to be handleEnd. So we're going to say self.handleEnd like that. We'll pass our screen. And then here we'll simply say pygame.quit. Now handleEnd is just going to be an end screen that's essentially going to say either your opponent left or you won the game or your opponent won. Whatever the end state is, the reason why you've kind of been kicked from the server, that's what we're going to show you. So we're going to say define handleEnd. We're going to take in self and screen. Here we're going to say run is equal to true. We're going to say while run. And we're going to do kind of a similar thing to this, except we'll just be displaying a pretty basic screen. So we're going to say for event in pygame.event.get. And we're going to say if event.type is equal to pygame.quit. Then we're going to say run is equal to false. Now that's just going to quit out of this while loop for us, so that's why we need that. Then down here, I'm going to say if self.client.winner. Now that means that if someone actually has won, right? So if we set the winner from our client, so if for some reason someone's the winner, we're going to say the text is equal to an f string, and this is going to say self.client.winner has won the game, exclamation point. Otherwise, so if they're not the winner, but for some reason we got kicked from the server, that means that our opponent left the game. So we're going to say text is equal to an f string of opponent left the game, ... like that. And then we're going to say content is equal to self.font.render. We're going to render this text, anti-aliasing 1, with 000. And we're going to say screen.blit. And we can draw this in the middle of the screen if we want again. The way I can do that is I can copy this right here. So let's copy that position. Okay. We can just change this to be text underscore surface. And now that will draw it in the middle of the screen for us. We could set up a function that does that, but for now this is fine. And then we're going to say pygame.display.update. And what this will now do is just essentially have kind of an end screen where we're displaying either someone won or someone left the game. And that's it. And then as soon as we hit the X button, we'll just close the window and that will be finished. So let's test this out. Server is still running. Let's start a client. Let's start another client. Let's open them both up. Okay. Move these over. Tim and Joey. Okay. And we're in. And 2. And 4. And 6. And we got an issue here. It says argument 1 must be pygame surface, not tuple. Okay, let's see where we're getting that. So text surface, screen. Aha, okay. So I forgot to put the text surface here. So I was just drawing this, not the actual text surface. That's why we got that issue. Let's run this again though. So put these over here. Tim and Joey. Okay, we're in. 2, 2, 4, and 6. And it says Tim has won the game. And then if we close this here, you can see that that just exits. And this exits as well. Okay. One more thing to test is what happens if someone leaves. So let's go through here, open up our clients. So Tim, and let's go with maybe Sarah this time. Okay. And if we leave, notice it says opponent left the game. Okay. There you are. Now I can close and we are all good. All right. So that is pretty much everything except for displaying the state of the opponent. So the whole idea is this is supposed to feel like kind of a live game, like an actual race. So we want to show on the side of the screen who our opponent is and what their current index is. So we know if we're ahead of them or behind them. Now, obviously, if we have more questions, that'd be more important. In our case, we just have a few lists of questions. You can obviously make it a lot larger, but anyways, we still want to display that. So we're going to make a new method here. We're going to say draw underscore opponent underscore data like that. We're going to take in self and screen. Now what we're going to do is say if not self dot client dot opponent underscore name, then we're just going to return, because if we don't have the opponent name, then we don't need to draw anything yet. Otherwise, we're going to draw what the opponent's name is, and then we're going to draw what question they're currently on. So we're going to say the name surface is equal to self.font.render. And we're just going to say here in an F string, let's go back, F, we're going to say opponent, colon, and then this is going to be self.client.opponent underscore name. We're going to go 1, and then same thing here, 0, 0, 0. Okay, so that's the name surface. Then we're going to say screen.blit. We're going to blit the name surface. I'm just going to hard code the location. So for the location, we'll go with 550 and 50. And now we want to draw what question they're on. So we're going to say the question number is equal to self.client.opponent question index plus 1, because we don't want to start at 0. We're then going to say the question underscore surface is equal to self.font.render. And we're going to render an F string and say question number. And then we will embed inside of here their question number. And again, 1 and color black. And then we will blit this on the screen. So let's just copy that there. Change that to question service and make this at 90. Might need to be a bit lower, so let's go with 100 actually. And now what we can do is we can simply go to where we have draw game, and we can either draw that right here, or we can just go inside of draw game, which is what I'm going to do, and say self.draw_opponent data and pass our screen. That should be good now. We should be seeing information about our opponent. So let's give this a shot. Okay, let's go Tim and Sarah. And you can see here that it says opponent Sarah, question number 1, opponent Tim, question number 1. As I advance, the question kind of moves up right in live time. Let's try it from over here. 2, 4, and you can see we're both on question 3. And then I hit 6, and it says Sarah has won the game. Sweet. All right, so that has been video 2. I hope you enjoyed this, and now you have a solid understanding of how these two systems interact with each other from the server to the client. In the next video, we're going to be handling the database deployment and deploying this server. That means we're actually going to take this off of our local machine, we're going to put this on a public network, and we're going to allow anyone that has our client application to connect to this server so long as they know the IP address. I'll walk you through all of those steps, but this is really where it starts to get interesting, and you can see how you do this on a larger scale. So outside of the localhost environment, how do we actually get a server up and running? How do we connect to that server? And how do we use multiple clients from multiple different devices on multiple different machines with this game? That's what you're going to learn in the next video. I hope you're looking forward to it. If you enjoyed, make sure to leave a like, subscribe, and I will see you there.